So to jump right into network and meter deployment, one of the kind of key components for our planning phase was to build in a pre-sweep or a pre-inspection program. So when our engineering and operations team designed the meter deployment plan, they did it by segment, which roughly correlates to zip codes. Not exactly, and it's not based on meter reading routes, but the segments that they designed, we decided to institute a pre-sweep of those areas. So it's a targeted look at problem areas within that segment prior to going and trying to mass deploy meters in that area. So we did a whole lot of work with other utilities and internally to figure out what that would look like, how many resources it would take, whether or not we had budget to do that, and then to kind of design the sequence of that so we could focus on the segments that we're going to deploy meters in. Really, I think it was to address the kind of the gas buildovers, the customer obstructions, things that have been probably problems and problem areas for many years but have not necessarily been addressed. So we wanted to get out in front of that and have had a lot of work around that program definition. And like I said, we learned from other utilities there as well. Maybe the next kind of big thing we have going on is we're calling it a field trial. It's a pre-deployment of a few hundred meters. So it's different than our pilot. BGE has a couple of pilots that we did in past years where we gleaned a lot of our knowledge in preparation for full deployment. But this field trial is specific to the vendors that we've chosen and specific now to targeted areas within our territory. And we want to test and validate the processes that we've designed in the last year or so to be able to deploy at high volumes. So it's a few hundred electric and gas meters and IMU modules to be able to test those operational processes. So hopefully we'll get a lot of good lessons learned out of that as well. Shanu, do you want to cover the next two?
Sure. So the next 2 points really relate to the sequence in which we deploy our network and meter on a mass deployment basis after that. Utilities normally do network design before start of any network deployment project, but during the course of the project do experience network coverage and signal strength issues. Also, meters in some areas end up being several levels deep, which can further impact communication, especially during outage situations and when the meters are deep within the mesh and will not be able to get connectivity due to outages in their communication path. The same situation is also true for cities where there are tall buildings and a lot of obstructions prevent signals from reaching the meters and communication without issues. So for this reason, while a network design can identify and address most of these situations up front, and that's the purpose of doing the network design up front before starting a network deployment, it's always recommended to keep a backup, a set of network components in reserve for such unforeseen situations. So that's the first point. The second point is around primarily the fact that even though you plan for network deployment to complete before the meter installs, it's really important to stress that point because your installer needs to confirm that mesh connectivity is available before they move on and call the job complete. And it's also important in situations where there is no battery backup on meters. Depending on your meter manufacturer and firmware, meters may require things like time information from the mesh for accurately recording interval reads. And once again, having the mesh before the meter deployment starts is imperative for that reason. The second point is around the determining of meter data and events required. And this is primarily around the fact that you need to finalize the channels of usage information that you would like to measure on, like kW edge, kVA edge, and timing frequency of your register reads up front so that you can use that information to finalize your meter programs. Also evaluate the type of information that your smart meter network can return back from the field, and this includes information like network statistics, voltage swells and sags, tampers, tilt alarms, etc., and ensure that your meter programs enable that information being sent to you. This is important so that you can avoid mass program updates over the air at the same time that your mass deployment is in progress. And these mass deployment projects normally last for several years. You don't want to be in a situation where you don't really know what the usage information and the events were required up front and have to do mass program updates while the mass deployment is still in progress and mesh may not have been completely saturated and reaching all the metering endpoints. For example, for gas IMUs, which are on 20-year batteries, reducing the number of over-the-air firmware upgrades also helps realize the full extent of the battery.
This is Jesse, Shanu. Before we move on, just a quick question. Bjorn asks, what were some of the biggest problems with the pre-sweep? And I thought it might be interesting for you or Jessica to mention the challenge that BGE has, of meters inside the premises.
Yeah, I think the biggest challenge probably so far anticipated and real is the customer obstructions. So bushes, decks, cabinets, things that are just obstructing the meter where meter readers may have been able to get the read, but we are unable to do an exchange. So
Right.
for decades, meter readers can get to that meter. Customers are good paying customers, but now we have to get to it and swap it out, and we're requiring them to allow us access to the meter. So there's new communications there. There's new outreach efforts, and to help them understand that the necessity, for the utility to be able to access the meter, and what it leads into the benefits of smart meters and all that. So it's a little touchy. We've engaged communications and change management training teams, a lot of people there, but it's primarily about getting into customer space and helping them resolve those obstruction issues.
The first point talks about the different types of accuracy demonstrations that BGE has instituted across the board to validate the accuracy of the meters and to make sure that meters record usage correctly, if not more accurately than the legacy meters do. And what we've done are basically a 5 set of points here that we've tried to do to be able to ensure that. The first one is the dual pan side-by-side read comparisons. This is primarily a legacy meter along with a smart meter, as you can see in the picture on the right side, installed at the same location to enable comparison of consumption reads and to quantify any variances in the cumulative reads over a period of 6 months, reads taken manually by the meter readers twice a month. This allows us the opportunity to really assure our customer base that the smart meters are equally, if not more, capable and accurate than the legacy meters that they're used to seeing in their households over a period of time. The second one is around dual pan manual reads versus over-the-air AMI reads. So this goes back to the point that Jessica made earlier around the field trial and the fact that for the set of field trial meters, we are doing both manual reads as well as comparison of the information coming back over the air into our SSN head end and comparing those two reads to ensure that what we are manually reading and what we're getting over the air ticks and ties and is accurate within certain levels of tolerance. The third point is around third-party meter accuracy testing. And here, as you mentioned earlier in our vendor slide, we're working very closely with Vision Metering to test samples of the smart meters being sent by the manufacturers. This allows for independent verification of the meters and helps compare results from BGE's own meter testing effort with those of the third party. So this is like a double check from that perspective. Image capture of the last reads. So this point was around the fact that as and when meter installers go out and replace legacy meters with smart meters, in order to better assure that the reads taken from the field are the ones that are accurate and that the customer would be billed accordingly, we also take photographs of the last read taken from the meter before it's being replaced, and those photographs are available to BGE on an as-needed basis and can be used for usage value verifications if and when needed for any customer requests. Secondary read validation. These are basically reads taken on legacy meters before they are exchanged and are validated by the installer in their warehouse. This validation again helps reduce any potential for human errors. The second point is around maintaining an adequate inventory, and this point is very relevant to utilities starting out with smart metering at this point. What we found was the same set of vendors are being asked by utilities across North America and across the world to be providers and manufacturers of their smart grid and smart metering devices and infrastructure. Due to this reason, we found that these manufacturers may be pulled in multiple directions, and we're not giving them a good perspective of what our timelines are and what our requirements are from a deployment perspective up front. We may run into situations where we may not have enough inventory in hand for us to be able to continue our mass deployment with our time schedule. So for this reason, what we did was we worked with our manufacturers to institute a structured process which on a periodic basis releases purchase orders of certain numbers over a period of 4 years to those manufacturers, and also provides them forecasts depending on the speed of our mass deployment and the actual execution of our mass deployment, provides them periodic forecasts so that they can meet our needs beforehand in a proactive manner. This also ensures that we have 2 months of inventory, of peak volume inventory, along with a certain contingency amount, so that for any unforeseen situations where the manufacturer is not able to meet our requirements, even though we did the two things we just talked about, we still will be able to continue our mass deployment and not run into situations where the installer has to let go of people because we don't have enough work, or cause program delays in our mass deployment, which can, as we all know, delay benefit realization.
And I'll take the last bullet, is about the processes that your internal crews are going to use to deploy meters. And I think it's important here, the day one piece. So we've learned from other utilities, and internally we've outsourced the mass installation to a professional meter installer. However, from day one, your own crews are also going to have to be able to react to storms, meter maintenance issues. There'll be new business where meters are going to have to be installed. So there are a few different good reasons for your own internal crews to also be ready to work on, exchange those meters from the first time you install one with your meter installer. In parallel to developing all of those integrations and all of that work to do mass deployment, we also had to focus on the business processes and system impact for being able to do that same kind of work internally, even though it would be on a much smaller scale. It's great work because you're going to have to do it eventually anyway. It was really just a matter of when. You know, could you put that off to some time further along in the deployment? Can you wait till you're really in the sustain mode? But internally, we decided that we wanted all of BGE's field service crews to be able to do it from the first day. So I think it's unique in just in the sense that you expect the project team to handle the network components during the deployment period, but meters are everywhere, and everyone in the field touches them on a regular basis. So that training, the communications, the processes, and system impacts had to be assessed and designed for day one for us.
Jessica and Shanu, Alice asked if when you did this testing, was there a difference between the indoor and outdoor connectivity levels?
Are you talking about for our field trial or our dual pan tests, maybe?
Yeah, but so as you were doing your first trials.
Great question. We hope to investigate that as well. Our dual pan actually begins the test. The letters to our customers went out yesterday, and we start to install those probably next week. I mean, the goal is by the end of this month that we start the dual pan side-by-side demonstrations. So we'll be able to begin capturing data and reporting on that in the coming weeks.
Thanks.
Mm-hmm.